So we've been using this equation to look at exponential growth and decay. When we had this equation, we would have a start value, which was our A, and a change factor, which was our B. And that change factor was always given to us in the problem, like saying it's increasing by a factor of 3 or decreasing by a factor of 2. Okay, today we're going to be doing problems that don't give us a growth factor. We're going to be looking at problems that deal with the growth in terms of percent. Okay, it's going to be a quantity that either grows or decays by a fixed percent at regular intervals. Now, when we talk about percents, we need to use one of these two equations instead of this original exponential equation that we were using. And these two equations deal with the percent instead of just having a change factor. Okay, now first of all, look at these two equations. They are exactly the same except for this symbol right here. When we have exponential growth, we're going to be adding, and when we have exponential decay, we're going to be taking away. Now hopefully that makes sense to you, because as things grow, they're becoming bigger, and when we add, things become bigger. And when we have subtraction, that's when things get smaller, and so we're going to have decay. Now, in order to use these two equations, you need to know what the letters, the variables, represent here. Our A is still our starting value. Okay, so just like up here, A represented our start, in this equation, A is also our starting value. Now, the 1 is always going to be a 1. And we're going to be adding or subtracting this value for R. R is our rate, the rate of growth or decay. Now the thing that's tricky is the rate will be given to us as a percent, but when we do these problems, we have to turn it into a decimal. And then finally, we need our X, our variable X, which is going to represent the number of times that something happens. Okay? And once you know whether you have exponential growth or decay, and you pick your equation, all we have to do is plug in these values and go from there. So here's our scenario. It says, to get a new computer, a recent college graduate obtains a loan of $450. She agrees to pay 18% annual interest. Now, interest is money you pay on top of the money that you owe. So she's going to have to pay back that $450 plus some additional interest. And the question we're being asked is, how much money will she owe, oops, there's a typo here, sorry about that, at the end of 2 years? So how much will she owe at the end of 2 years? Now, because I said this is a problem where interest gets added on, we're talking about exponential growth. So we're not going to look at this exponential decay equation at all. We're just going to look at exponential growth. And what we need to do this exponential growth problem is the values for A and R and X. So A is our starting amount. She started off borrowing $450. So that's my starting value. Now my rate is the percentage rate. It's going to be 18%. But remember, we have to turn this in and express it as a decimal. So we would have 18% is 0.18. And then X represents our time period. The question is, how much will she owe at the end of 2 years? So X is going to equal 2. And once you've identified those points, all we got to do is take them and plug them into this equation. So it's going to start off Y equals, and my A value, I'm going to put right here, $450. And then I'm going to have my 1 plus my rate, because it's exponential growth, so we're going to add, and we're going to add in our rate, which is as a decimal right here, 0.18. And then finally, we need to have our exponent, which represents my time. So it's an exponent of 2. Now we are going to use a calculator to help us out. And this calculator right here is through Desmos. It's desmos.com/scientific. That's a good calculator to use. And what I can do is I can just write in this entire expression over here. So we're going to start. I'm going to type in 450 and then my parentheses, 1 plus 0.18. Then I have to close my parentheses, and finally I'm going to raise it to the power of 2. So this button right here is going to give us that exponent, and I just need to put in the power of 2. When I hit enter, that's my answer. So y equals 626.58. Now remember, this question is money. How much will she owe at the end of those 2 years? So what she's going to owe, I have to write this again as money. She will owe $626.58. So that's an example of exponential growth. Let's look at an example that shows exponential decay. So I kind of gave that away. This is a decay problem, but I think you'll see that as we go through. So here we go. Our car cost $42,500 when we purchased it in 2015. The value of the car decreases, that's how we know it's exponential decay, it decreases 15% annually. And we want to know, how much will the car be worth in 2022? Okay, so it's exponential decay, and we need to identify these values here. So my starting amount, remember, that's how much my car started at. My rate is my interest rate, or my, in this case, my depreciation rate. It's depreciating at a value of 15%, which would look like 0.15 as a decimal. And then last but not least, we need to know how much time we're talking about. Now, some people would put 2022 as our time period, but that means we're talking about 2022 years after when we started. So that's not going to be the answer. So what we want to do is we want to do this subtraction problem. From 2015 to 2022 is 7 years. So my time is actually 7 years. And then we're going to do this problem. So here we go. Remember, decay, so it's got a minus sign here. We're going to start off. Y equals. My A value is my starting amount. We're going to plug this in. 42,500. And then we have our 1, and this time we're subtracting the rate because it's decay. So minus my rate is 0.15. And finally, we have to raise that all to the exponent that has to tell us how much time is going by, which is 7 years. And so now, to find this out, I'm going to take this whole expression, plug it into my calculator. So $42,500 times 1 minus 0.15, close your parentheses, and raise it to the exponent 7. So right here, that button, 7, hit enter. Now, check out this answer. Crazy answer. We've got 1,3,624 with a decimal point. 5,2,6,2,5. Okay, this is money. How much will it be worth? So what we need to do is we need to make this look like a money amount. Okay, money only has up to the hundreds, only 2 decimal places. So what we need to do is look at this and decide, are we going to be rounding here? Since 6 is greater than 5, this number will round up. So what we really have is our car will be worth $13,624.53.